Okay, the last thing I wanted to review for the exam is how to handle air resistance, if we have air resistance. So let's think about a projectile. So it could be, similar situation that we were just looking at, somebody throwing a ball, but maybe now they're going to launch it off a cliff. So let's make that go a little bit higher. So let's look at the motion kind of right in here if the projectile is there. So we can look at a free body diagram. Put our coordinate axis in, just x and y are horizontal and vertical. The forces acting on the ball, we have gravity in the x direction, and if the object is moving in this way, that's our velocity. Drag will be opposite that. I probably made that a little too big. So let's make drag like that. Okay, so if we wanted to determine our acceleration, we would apply Newton's second law. Sum of the forces is mass times acceleration. We're just looking at our free body diagram here, so each force we would break into its components. So we'll put a column vector in there, and then that's going to give us mass times acceleration in the x and mass times acceleration in the y. And then we have minus Fg for gravity, so this is our gravity bracket, and then this would be our drag bracket. And then drag, we have minus Fdx and minus Fdy. Right, so if we were looking at Ft, that would be the x, and that would be the y. Okay, so if we want to know acceleration, we look at the x equation first. So we have minus f dx equals m ax. So our x acceleration is minus force of drag in the x direction divided by the mass. And we could be more specific with drag. We know that is 1/2 c, which ends up being about 1/2 to the density of air, cross-sectional area, v squared. But we want the x component of that, right? So this would be ft cos theta, and this would be ft sine theta. So if we do ft cos theta, then we have 1/2 c rho a v squared cos theta. And now we can break that v here into, leave one speed by itself, and then the other one is v cos theta. This is vx, right? V cos theta is the same as vx. So if we put that all together, our acceleration in the x direction is minus 1/2 c rho a over m v cos theta, which is vx. Okay, and then in the y direction, again back to our, we have the minus force of gravity and minus the force of the drag in the y direction. So we have minus Fg minus force of drag in the y direction equals may. This is minus mg. We can make a similar argument here for the y component. So we have 1/2 c rho a v vy equals may. Okay, and if we want to solve for ay, we just divide through by mass. So ay equals negative g minus 1/2 c rho a over m v vy. Okay, so that's just quick review of how we go from the free body diagram to breaking the forces into the components and solving for the acceleration in the ax and ay direction.